All right, folks, thanks for joining us today for our webinar, which is on voice network fraud and how to fight back with automated threat prevention. My name is John Ryan, Channel Marketing Manager here at Ribbon, and today we're really going to be looking at the strategy that we're seeing enterprises do for network security. And then while there are good strategies, the voice network is generally not always looked at. And so we're going to really be talking about the threats that may be trying to infiltrate your voice networks already, the best practices for voice network security, and some tools from an analytics and machine learning perspective that can help you prevent bad actors from infiltrating your voice network. Our presenters today are two fine gentlemen who have been part of the Ribbon team for many years now. First is Dan Teichman, the Director of Product Marketing. And then we also have Ram Ramanathan, Senior Director of PLM for Ribbon. They're going to be presenting today. If you have any questions, please feel free to put them in the chat window and we'll get to them as soon as we can. And also, please be aware that we will be sending you the replay of this webinar within a couple of business days. And that's it, folks, for that preamble. Now we'll get things over to Dan Teichman for the webinar. Dan, take it away.
Thanks, John. Good morning, good afternoon, and maybe good evening, wherever you might be listening. Ram and I are looking forward to sharing our insights today on voice fraud and what can be done to both identify and prevent it before it disrupts business. So for the agenda for here, we will be talking a bit about some of the challenges of voice threats. What are the attributes of a voice threat prevention solution? What is Ribbon offering in this space? We'll walk through a couple actual use case examples, and we'll wrap that up. And along the way, please, as John said, if you've got questions, please enter them in the chat window. We want to make sure we address everybody's questions. All right, let me start with the challenges. So the first challenge when dealing with voice threats is that most enterprises make their security investments that are focused on data. And absolutely, that's certainly valid. I have no issues with that. But as we'll talk more today, it's not a complete story. So while people are investing in SIEM, zero trust, focused on malware detection, intrusion detection devices, et cetera, there's also next-gen firewalls that many enterprises we tell us, I intend to use that for my VoIP traffic, for my voice over IP services. The thing is, though, I want to touch on that a bit. It doesn't really work for voice as well as people might think. We actually have some vendors of next-gen gateways who have told their clients, their enterprise customers, to actually not use the application layer gateway function because it can break some voice calls. Furthermore, next-gen firewalls don't police VoIP ports for bandwidth, so that can lead to conditions where bandwidth is overloading ports. That's bad. VoIP ports don't get closed by next-gen firewalls when a session's completed because they're not session aware. And SIP parsing is limited on those firewalls. So there's limitations on seeing unwanted traffic. So you'll hear more from us today about what you can do instead of using next-gen firewalls. But what you do need to know is if you're using an IP, PBX, unified communication solutions, contact center solutions, you're at risk for data exposure, for financial loss. So this second challenge is really corporate awareness, right? I'm saying you guys need to think about this and incorporating what you do. We'll look more about that as we go farther in this webinar. And the third challenge is multi-vendor. Invariably, if you have VoIP services and infrastructure deployed, it's a mix of vendors, or it's a hybrid cloud on-premises solution. And that's actually fine. We expect that. But that challenge is that what that means is you've got to have a way to manage your VoIP security across different vendors, okay? And while that's, again, not necessarily a problem, it's something you need to be aware of and what's important to address it. And finally, fundamentally, voice applications and services have users that are remote. Increasingly, those applications and services are provided from the cloud or in a hybrid solution. And what that means is your attack vectors have gone up significantly. And so we want to talk about that and talk about how we address all these things today. So let's talk about my last point for a minute, the attack vectors. So in the traditional voice world, seen on the left of the slide here, right? Most everything was inside a secure domain, right? Attacks had to penetrate one or more systems and then attack the VoIP servers or network investments or desktops or whatever you might have had in place. But in the new world we live in, which is realistically what that looks like, get that to advance. Okay, interesting. There we go. Sorry about that. In the world we live in now, voice assets are distributed. They're located in data centers and or cloud-based or hybrid. Users are remote, whether they're call center agents, whether you're just your normal everyday people working in your company. And certainly work from home, as we all know, exacerbated that shift. So what's happening in this new world, though, is attack vectors are now happening everywhere. And I'll give you a simple analogy. You've locked your doors, you've locked the windows in your house, you installed a security system, but you forgot about the side window in the garage, and you don't even know it's unlocked because you think it's locked. It's really about understanding that voice can be an open door into your enterprise, and people can do bad things with that. So how do you stop that? That's really what we want to talk about today. So if your enterprises, your businesses are at risk because you have these things we just talked about, what do those risks look like, right? I can't just generically tell you that there's risk. Let's talk a bit about some of the details. So spoofing, that's manipulating caller identity to make it look like to the recipient or the called party that the call is coming from a legitimate person or another business. That allows traffic in, people answer phones, bad things can happen. Not necessarily telling you you're going to avoid these calls, but maybe you want to know if potentially these calls are spoofed or not ahead of time. Robocalling. Robocalls are not all bad. Many of them are, but there's legitimate purposes for outbound robocalling. There's legitimate purposes for people who receive robocalls, right? The challenge here is that auto dialers and people making malicious or unwanted calls are doing it with the intent of interrupting business or wasting call center resources, right? Or trying to get someone to answer the phone so they can then attempt to defraud them. Robocalls are important to understand. DDoS or TDoS, so distributed denial of service attacks or telephony denial of service attacks, which are a form of DDoS attacks, are automated high volume traffic that's targeted at phone numbers so that normal business services are overwhelmed with malicious calls. Some of those calls may not even get through, but it's preventing good traffic and wanted traffic from coming through. And it doesn't matter what size your company is. This happens all over the place. Then we have hacked UC or PBXs. So again, either on your premises, or potentially in a cloud service that you might be using, the potential exists for people to illegally access those systems to then in turn use your resources to make things like outbound calls that you, the enterprise, have to pay for. Maybe the bad actor isn't actually making any of those calls. Maybe they're selling access to people who are using your resources to make calls. They're just the enabler. In either case, not a good situation. And finally, we have fraud, right? So fraud is a category that I could basically say is any method of generating revenue through fraudulently collecting or selling stolen data or using resources illegally to cause an enterprise to have to pay for traffic they don't want to receive. So a simple example is if you have a 800 number or an 8XX number and you use that for your outbound marketing, bad actors can pump up that toll-free traffic. It's not traffic you want, it's bad traffic, but you have to pay for it because you're paying for every call that comes through to you. So how do you address these things? What do you need to do? And lastly, I want to point out, we've got ransomware. So an increasing percentage of attacks, especially what we see with TDoS attacks or a hacked UC or PBX system, is that they'll be followed up by a ransom demand to stop the attack. All of these things are things that you need to think about, plan for, deploy solutions for, and address to mitigate the problems. So what I want to do here is I want to show you two examples of one example, which is toll fraud, and just give you two examples of toll fraud and show you how costly it is with a couple of customer examples that I'm aware of. So the first one was a Fortune 500 legal consulting company. They had no idea that they were under attack. Their upstream SIP trunk provider, their carrier, notified them that they were seeing a high volume of traffic that was going outbound to international calls. That was probably not something they were normally doing. They, like I said, they didn't even know it. So an investigation revealed that there was a conference bridge that had been hacked. It looked like the traffic coming into them and then joining the conference bridge for outbound calls was a legitimate inbound DID, but it wasn't. So while this occurred multiple times over a month and amassed these charges of over $100,000, they finally decided, oh, this is a problem. They figured it out. They told their carrier, please block that calling party number. They did. The problem went away temporarily because the issue returned, the bad actor used a different calling party number, and the entire scenario played out again. They didn't have a solution in place to be able to detect these things and detect them very rapidly. Second example, Fortune 100 multinational food manufacturer. They did suspect that they had some telephony theft going on, and the problem they were seeing was something called dial-through fraud. So their investigation revealed that an incoming trunk that they had coming in for traffic was repeatedly seeing traffic coming from the same caller party number over and over and over again. But it was getting into their system and then turning out and dialing back out to Europe. Clearly, again, someone was coming into their system but had access to dial out. So they lost over a 1 month period approximately $200,000 before this was determined. Again, the only reason I bring these things up is that it raises the issue that we have solutions that need to be in place to figure these things out and stop them as rapidly as possible. So with that, what I want to do is run a poll question next. I want to gauge the importance of voice security to your company's security strategy. So John, if you could put that poll question up.
Yep. So folks, please feel free to select one of these options, either extremely important, someone unimportant, not important, or you're unsure.
Hey, Ram, what do you think is gonna be the results of this poll question?
I would think based on discussions with customers and partners and so forth, I would think most of the, without biasing the poll that's open right now, I would think that most of the responses will be in the top two buckets, extremely important and somewhat important. That's my guess at this point.
And that's my hope as well, but we'll see what we get, and we'll show some market research that might give us some indication of how well things are going out there.
Excellent. So I just closed the poll, and we saw the results say 83% said extremely important and 17% said somewhat unimportant.
Well, that's interesting. So 83% extremely important, John, you said?
Yep, and 17% of somewhat unimportant.
Interesting. Okay, well, let me move on here. I want to talk about some market research and how it lines up, and then we'll talk a bit about those poll results. So Metrigy, again, I wanted to run that poll result because I want to see how it matches up with these results from Metrigy. So they ran a report, a survey in September of 2021 called UC Management and Endpoint Survey. And in that survey, they included some questions about voice fraud. So from their survey results, right, it was clear that 80% here thought that voice security was an important part of their security strategy. That lines up really well with the results we just heard, right? However, what was also interesting on those same results was they asked the question, do you have a strategy to prevent voice toll fraud in your organization? And it really was, if you look at the answers over here, it was really around not the importance of it, but are they actually doing something about that? And so less than 50% shown here on the right, had included voice in their strategy to address it. So even though they thought it was important, they hadn't really gotten around to including it. And even more concerning was this 21% that had no strategy at all. Now, this was run survey in 2021. So you do see that there were some people planning on doing something in 2021, as well as people planning it for 2022. So what I think is interesting here is the survey results lined up well on the left. The actual implementation may or may not be following up with the intent. And we're going to talk today about implementation and what you can do to actually do this. So with that, let me go ahead and move on. I want to talk about this from an implementation perspective. Metrigy also asked the survey respondents, how did they plan on implementing voice/toll fraud solution? And so a good side note, it appears the Metrigy survey allowed participants to answer this as a multiple choice, since the percentages add up to more than 100%. But as you can see, more than half intended to use a cloud-hosted solution. Now that they, again, 35% said they were going to use their own tools. So some of those may have been cloud-hosted, but my guess is many were potentially using third-party cloud-hosted services. And my guess is that percentage is probably higher now if that same question got asked. A third said they would use their own tools. A quarter were not sure, and 17% said they would expect their SIP trunking provider to provide a solution. And that's interesting. We absolutely believe that the SIP trunking providers, the service providers they're connected to, as well as managed service providers can offer these services. So again, all of this is in play, and given the poll results, I'm assuming of the 80+% that thought it was important, they've thought about how they might implement it. Less so obviously for the people who thought it was somewhat unimportant. But I think, and I hope that through this webinar today, we can get people to understand that it's probably more important than you think, and there's ways to address it without a lot of burden. So with that, I'm going to walk through the key attributes of a voice threat prevention solution and give you guys an idea of what it is that you should be looking for when this occurs. So anomaly detection. Nothing happens if you can't detect the anomalies that indicate that you've got bad traffic. So these are going to be machine learning models to identify the voice threats, machine learning models that continuously learn based on traffic. And they're automated. The only way to do this is to have an automated system that's constantly looking at the incoming traffic, and potentially if someone's hacked your PBX and is making outgoing traffic, the outgoing traffic in the enterprise to determine anomalies. So this is done by looking at traffic, determining the baselines, understanding what is normal traffic, and identifying anomalies. That information is then made available to other machine learning models that are going to provide reputation scoring. And those reputation scoring that's critical because a potential threat, the anomaly detection, is just a potential. Now, it might be pretty clear to some that it's an attack, it's a TDOS attack, it's malicious intent, and I have to stop it. But in many cases, the nuances of what's good or bad is more complicated. So by determining one or more reputation scores that can be associated with each and every VoIP session, it's going to be possible to make an informed policy decision about how that traffic should be handled. And so those policy decisions that get made based on reputation scoring are then going to feed policy enforcement, which is obviously the critical piece. You need a way to actually apply some mitigation rules and stop the bad traffic. I mean, that's the goal. Identify the bad actors, identify the malicious traffic, and stop it. And so policy decisions may decide, hey, this is good traffic. I should let normal call setup happening. It may decide there's other ways I want to handle this. And then lastly, after this takes place, right, and bad traffic is being stopped, more bad traffic still coming in, but some of it's being stopped. All of that affects the traffic mix that's going to be seen by the anomaly detection function. And this just process runs and runs. I'd like to say that enterprises will get ahead of the bad actors. I'm not sure that's the case, to be honest. Bad actors are going to innovate and keep doing things, but you can keep up with them with automated systems that allow this to happen. And with that, I'm going to go ahead and turn it over to my colleague Ram and let him talk about what Ribbon's offering for a voice threat prevention solution.
And Dan, I'm glad you mentioned that. I have a quick question we just received from the audience. The question is, if we have a voice threat detected, can the Ribbon session border controller give us an alert and send some sort of alert to their IT team?
Yes, that's possible. But then the IT team has to do something, and then they have to decide what to do. And then, first they have to analyze it, then they have to decide what to do, then they have to go make some changes somewhere to invoke something. What we're going to talk about here today, which does include an SPC as part of that policy enforcement, is how that should be automated and made much more efficient.
Perfect. Thanks, Dan. All right, off to you, Ram.
Okay, very good. Thanks, Dan. So just before I get into the ribbon aspect of the solution, I would like to kind of recap some of the key points that Dan made. So he started off by saying the world is different now, right? It's not anymore an enterprise bound to certain physical domain, but it's really open where people work from home, different parts of the world. So the aperture of the enterprise has really broadened. So that's one key aspect of the changes in the last few years that have taken place. The other aspect is, people tend to focus on the data side of security because that's the one that makes news. The different kinds of attacks we have seen with different enterprises. But the voice side of the things are often an afterthought. But then, as we are seeing in the market, there are different types of these voice attacks that happen. And in some points, it's not just a question of the enterprise having to pay up money on toll fraud and so forth, which is important, but also it strikes at their capabilities, the business capabilities of their contact center or their corporate network, which cannot function at the full scale. So there is a business aspect, impact aspect of this, and there is a cost aspect of it. And we're starting to see this more and more in enterprises, in carriers around the globe, actually, because people are now targeting the voice infrastructure because it's not as protected as the data infrastructure. So there was a question of what's changed in the last few years, and then why is voice security important? Then the other aspect that Dan talked about was the attackers or the bad guys are not using a single method to attack your network. There are multiple methods, and it's evolving, and any solution that we pick should keep up with the evolving landscape. So it's not one size fits all. It needs to be a dynamic infrastructure that handles security not just for today, but into the future. So that's another aspect of any solution that we look for should be more adaptable and dynamic. So those are some of the points, and he brought out some of the facts from the analyst side. What are they seeing in the market? What are customers seeing in the market? And most customers and partners and analysts see that this is an important problem that we need to solve. While all enterprises may not have a roadmap to get there, but we just wanted to highlight and educate the market that this is happening. It's important to recognize the issues and then go forward with a solution in multiple phases. So with that, I'll go into how Ribbon plans to tackle voice security and fraud mitigation. So we call our solution voice threat prevention. So the umbrella is called voice threat prevention. There are multiple products within the umbrella. But at a high level, what we need for an effective voice security solution are three pillars. Two are shown here. One will be built out. Basically, you need a really capable anomaly detection function. This is a high, big data analytic system with AI, ML models that keep up with the changing threat landscape. So you need a really effective analytic system that looks at all the data that happens that are collected in an enterprise and looks for those behavioral patterns and any anomalies that go above and beyond the regular behavioral pattern. So analytics is a key component for anomaly detection, and we have a product called Ribbon Analytics, which kind of fits that pillar or that role in the voice threat prevention solution. The second pillar is what we call reputation scoring. So it's not just enough to detect anomalies. We need a way to calculate metrics based on the anomalies and come up with scores, real-time scores that can then be implemented or enacted in the network. So anomaly detection is the function that detects and brings to the fore what are the issues with the network or any anomalies in the network, but then that needs to be converted to something that's real-time scoring, which can then be acted upon. So in the case of Ribbon, we call it a product called reputation scoring. This is a SaaS product that runs in the cloud. While analytics runs on-prem inside the enterprise, reputation scoring runs in the cloud, which is a Ribbon managed service. So together, analytics, which looks at the on-prem behaviors, provides anomaly detection on-prem. Reputation scoring, which I'll cover in the next few slides, runs in the cloud, which is a ribbon managed service, which will also get global data. It's not just the local enterprises data, but reputation scoring gets global intelligence from third-party databases, from fraud databases, from our own honeypot service that we run. So it gets global intelligence, and then we mash up the local behavioral anomalies and the global intelligence, and then we come up with a real-time score that can then be acted upon. So analytics on-prem and reputation scoring in the cloud really act together to create this voice threat prevention solution from a ribbon perspective. Now, once, if you can build that one more time, Dan. So once we have the real-time scoring based on anomalies detected in the network, and then anomalies or intelligence gained from the global network, once we have that combination and create a real-time score on a call-by-call basis, we provide that score to the policy enforcement function. In the ribbon case, it could be an SBC. If you just click one more time, Dan, it could be a ribbon SBC that acts as the policy enforcement function. So the score gets to the ribbon SBC, and depending on the configuration, if it's a high score, we can block the call, or the SBC can reroute the call to a lower cost destination or a lower cost contact center. It can redirect it to a voicemail, or it can outright block the call. So there are many actions the SBC can take depending on the score that it receives from the reputation scoring system. And again, back to the question that was asked a few minutes before, can the SBC just provide alerts? So we can absolutely do alerts. And some of our customers, initially don't want to implement automation. So if they want to just learn from the system, look at the patterns and look at the threats that are happening in the system from an alert perspective, we can absolutely start off with alerts. And then once the customer, the enterprise gets comfortable with the system, then we can automatically take some of these actions along the way. And then the key part tying all of this together is the visibility part at the top. So dashboarding and visibility and reporting are key aspects of the solution where we provide a window into the mechanism of how this whole system works. And here's where we can report on threats. We can report dashboards on how many calls were blocked, how many calls were rerouted, what anomalies were detected. So we provide the full end-to-end visibility across this solution, the voice threat prevention solution, from a ribbon perspective. If you can go to the next slide, so it's a slight variation from the previous slide. It still has the 3 pillars: the anomaly detection on-prem by analytics, ribbon analytics, the reputation scoring running in the cloud as a ribbon managed service, providing the real-time scoring. But then here, the enforcement is slightly different. There are networks that have just the ribbon SBC, and we can absolutely take action at the SBC level. But there are networks that use also a ribbon PSX, which is a centralized routing engine. So in cases where there is a PSX, the SBC uses the PSX for routing and policy information. So in cases where there is an SBC and a PSX, both of them can join together to provide the enforcement capabilities like I described before. We can block calls, we can reroute calls, we can send calls to voicemails, and there are different types of policy enforcements we can take. And one of the recent ones, for example, we had implemented was, if we think that we don't know if it's a good call or a bad call, can we challenge the caller with a CAPTCHA? And in this case, it's going to be a dialed number, so we can say that if can you press these digits before you proceed with a call, and the user presses those digits, then the call is let go. If not, we block the call. So there are multiple ways of enforcing policies, and in this case, the SBC and PSX work together to enforce policies. Next slide, Dan. Okay, so those are the 3 pillars from a voice threat prevention solution: is the anomaly detection analytics, reputation scoring for real-time score creation, and then SBC and PSX for policy enforcement. Now, when we look at a network, and this is a sample of an enterprise network, so there is typically a telecom provider on the northbound side, typically a SIP trunking provider, and then you have an SBC typically on-prem on the enterprise side that acts as kind of the voice firewall, even though firewall is not a good term for the SPC. It's, we can at a high level say it's a voice firewall. So SPC acts as the demarc point between the SIP trunking provider and enterprise. And then once it come, inside of the network, then you have the contact center PBX, and then the enterprise users, the end users sitting behind the PBXs. And in some cases, there could be multiple PBXs, could be some of them IP PBXs, some of them cloud-based UC services, and so forth. So that's kind of the sequence from the SIP trunking provider to the SPC to the PBX to the end users. Now, in the past, the SPC was regarded as the first point of entry that can basically protect the whole network, which is still true. But the SPC looks at a much lower level of data than what the voice threat prevention would look at. So SPC looks typically at SIP messages that come in, looks for malformed packets, looks for the amount of packets that come in, the amount of calls that happen at any point in time. So the SPC can look at data at the SIP layer, and it can detect attacks and mitigate those. If there's a DDoS attack, the SPC can detect that and mitigate that. But the SPC acts at the SIP layer. Where the voice threat prevention comes in is at a layer much higher, because it may not look like an attack or a malformed packet to an SPC, but at a higher level, calls are being made from the same number, or calls are being made to IRSF, International Revenue Service fraud destinations, which the SPC cannot detect on its own. So the SPC can work at a lower layer, but we need a solution at a slightly higher layer to detect these fraud scenarios. So it's really multi-layered protection is what this solution provides. So in this case, the SPC acts together with analytics and reputation scoring, as we described in the previous couple of slides. And then together, the solution provides real-time scores to the SPC, which can then take action, not just at the SIP layer, but then at the higher layers, it can look at the call and then look at the score and decide what to do with the call. So it's really multiple layers of protection is what this solution provides, as opposed to an SPC that works at a single layer, the SIP layer. Okay. Next slide, Dan. Okay, so now let's look at some of the use cases. We'll talk about a use case on the inbound side when calls are made to the enterprise, and then we'll look at an example of an outbound call when calls are being made out to the SIP trunking provider. So first, the inbound use case. So this is an enterprise on the right-hand side. It's a traditional, let's say, a contact center with a PBX with a bunch of users or agents sitting behind the PBX. Some of them could be within the enterprise boundary, some of them could be remote. And in the middle, you have the SIP trunking carrier, and on the left-hand side, you have the callers. In this case, these are legitimate callers, or in some cases, robocalls could be legitimate, as Dan described. So these are legitimate callers shown by the green arrows, making a call into the enterprise. These are inbound calls from an enterprise perspective. And these are good calls, and they make it through the SPC, make it through all the way to the agents, and everything is good so far. Now let's click one more time. Let's bring in the bad guys. These are the red arrows from the people that make DDoS attacks, where they pump a lot of calls into the network. These are typically done by machines, not by real users, but by machines. And they try to bring down the contact center network by taking up ports on the SPC or on a TDM network. And then there are callers that are fraudsters that are traffic pumping and basically doing IRSF fraud. And I'll talk about IRSF in the next slide, but basically fraudsters trying to make money off the enterprise. And then there are the regular nuisance calls. These are the telemarketing calls or calls. They're just a nuisance. It doesn't leak money, but it's going to tie up circuits. It's going to tie up the users, the end user agents' time, because contact centers, they want to maximize the time the agents spend with customers as opposed to non-customers or nuisance calls. So the red arrows show basically the bad guys coming into the network at the same time as the good calls. So it's up to the network now to detect what are good calls, what are bad calls, and then keep going. So in this case, the bad traffic, the malicious traffic hits the SPC first. And if you did not have the voice threat prevention solution and you just had the SPC, in most cases the SPC cannot detect from a good call from a bad call, because this happens at a higher layer than the SIP layer, as I described before. So now if you click one more time, Dan, now we bring in the voice threat prevention solution using analytics that sits within the boundary of the enterprise that's shown in the picture, that looks at the enterprise's traffic patterns and detects anomalies, and then feeds it into the reputation scoring, which is a cloud-based ribbon managed service. It feeds in the anomalies that it detected into the cloud-based system. The cloud-based system gets information, insights from the analytics system inside the enterprise, but it also gets third-party information globally from fraud databases, nuisance databases, and also from a ribbon honeypot service. It gets global intelligence as well. So the reputation scoring is going to combine the local intelligence from analytics and the global intelligence, and it's going to come up with a real-time score on a call-by-call basis. So now, once reputation scoring has this intelligence, the SPC dips reputation scoring on a call-by-call basis and gets the real-time score. So the SPC, when a new call comes in, and let's say that is the red arrow coming into the SPC, it queries the reputation scoring service, gets a real-time score, and if it's a bad call, if it's an IRSF call or a TDOS call, it's going to block it right there. And if it did not have the voice threat prevention system, the red arrow, the red call would have gotten all the way to the PBX and all the way to the end user agent. But with this threat prevention system, the SPC is now going to look at the real-time score from the reputation scoring, and then it's going to block the call or reroute the call as the policy that's been set by the enterprise. So with this, the bad calls are blocked from the enterprise network, and the enterprise can just focus on the good calls as much as possible. So this is an inbound calling scenario where the SPC, along with the analytics and reputation scoring in a closed loop, is going to mitigate fraud and robocalls and keep the network protected from those bad traffic and keep the network going so the agent's time is spent on useful end customer calls. Okay, let's go to the next slide where we can talk about outgoing calls. So the previous slide, we talked about incoming calls, but equal threat is also there on the outgoing calls. In this case, the most common use case we see is bad actors that can take control over a PBX. So they hack into a PBX and start making outbound calls to international revenue service fraud destinations. This could be domestic revenue service fraud or international revenue service fraud. But what happens here is the bad actor has a premium rate number that he leases from a local carrier, either within the country or outside the country. And the bad actor tries to pump as many calls into that number that he has leased so that he or she can get money from the carrier for the premium rate traffic that hits that number. So basically, lots of traffic needs to come towards that number for the bad actor to make money. So here what happens is the bad actor now, once he leases the number, the premium rate number from the local carrier, he's going to take control of the PBX and then start to pump in calls into the PBX, which then makes outbound calls towards the premium rate number. And that is how the bad actor makes money. So now if it were just the SPC, doesn't matter if it's a ribbon SPC or a third-party SPC, if it were just the SPC, then the SPC cannot detect this kind of fraud because it doesn't happen at the SIP layer. It really happens at the application layer. So if you click one time, Dan, so now we bring in the voice threat prevention solution with analytics and reputation scoring again. Now analytics is going to detect that something is happening, something fishy is happening, because the behavioral patterns that the analytics knows about is not the same as what's happening now, because there are calls being pumped to a destination that we have not seen before. So there is an anomaly. Could be, I mean, some anomalies, not all anomalies have to be bad calls. Some anomalies may be regular. So we need to really, first of all, detect the anomaly, then see if it's a regular anomaly that is considered good, or is it a bad call. And those are then fed back into the reputation scoring system. And then when the SPC gets the call, it's going to do a query into the reputation scoring system and gets the real-time score. And in this case, it's a bad call that is going to an IRSF destination or a domestic revenue fraud destination, and the SPC is going to block that call based on the score returned from reputation scoring. So the function that voice threat prevention does for inbound calls and outbound calls is pretty much the same. It's anomaly detection, looking at the information in the local network and the global intelligence, and coming up with a score that can then be acted upon by the SPC. Just that the methodology of fraud is different between the incoming and the outgoing calls. And as we discussed before, now these are two use cases. There are tens of use cases that bad actors use to defraud an enterprise network. And this keeps evolving. So we need a system like analytics and reputation scoring that evolves to the threat landscape in the marketplace. And as there are new threats that are coming up, sometimes we may have to do newer machine learning models to accommodate newer threats. But this system needs to be adaptable to newer threats as we go forward. So these are two common use cases we have seen in networks, with some of our customers. And this is an effective solution from a Ribbon perspective to mitigate fraud and robocalls and keep the enterprises basically to keep the users, the end user agents, engaged with real customer calls as opposed to dealing with nuisance calls and fraud calls.
Ram, I want to add in one quick point based on that earlier question as well. So as you can see here, once this is determined, the bad actor is still hacked into the UC or PBX solution, right? But their traffic isn't going through, so they're not making any money. That means somebody figured out how to stop it. They're probably going to stop their attack, or they're going to try some other avenue. What the question that was asked earlier about the SBC notifying an alert, in this case with the dashboards and the reporting, you'd be able to see that this happened. So somebody still needs to investigate how to kick this bad actor out of the UC or PBX system, but now you know it's happened and you're also stopping it from affecting your traffic. At least your outbound traffic costing you money in this case. So I think it all fits together based on what we're looking at and what Ram just described. So Ram, let me move on to the next slide then.
Yep. Okay, so kind of to wrap it up, again, we wanted this to provide an insight into what we are seeing in customers' networks and what are some of the common use cases, so that'll start a discussion going forward. And to wrap up, just to bring this loop, the closed loop system here, basically what we're looking at is there are threats that are evolving. There are new threats because of the change in the last couple of years in terms of how the enterprise boundaries have expanded from where they were a few years back. And there are newer threats coming up every day. So we need a system that's adaptable and dynamic with kind of an analytic system that detects anomalies on a near real-time basis that feeds that information into a real-time reputation scoring system that also gets information from global databases and then feeds that into the policy enforcement function, SPCs and PSXs and so forth, which can then take action on a call-by-call basis. So it's really a closed-loop system that learns along the way and adapts itself to the growing threat landscape. And as we get into newer threat models and so forth, the system keeps evolving and protects the enterprise from voice fraud, which is kind of coming to the fore at this point as we looked at the marketing reports. So this is something that Ribbon is focused on and providing a complete solution as opposed to a piecemeal solution. This is a complete solution that protects the enterprise networks from voice fraud. There's some more information at the link, and I believe, John, these slides will be shared. So there's a link at the bottom that can provide more information on the Ribbon voice threat prevention solution.
Yep, thanks, Ram. We'll definitely get that link out to folks after the webinar, and we'll also get the slides as well. And we do have a few questions that have come in I'd like to read out here. The first one, we had a question from Peter. He said, what he's really looking for is details into the actual analytics applications, such as subscriber protect, fraud protect, etc. So how can Peter get more information on those actual analytics applications for him?
So yeah, we can, good question. So we can absolutely send more details on analytics applications. So the question on multiple applications analytics, it's absolutely true in the sense that it's not one monolithic system. Analytics has multiple applications within it. Some of the applications are related to fraud detection, fraud mitigation. Some of them are for operations and troubleshooting. So we can certainly send more information about the different applications that analytics has and the applications that pertain to the solution as well.
Excellent. Great. Another question we have is, well, I already have Ribbon Analytics, so what needs to be added for this my solution become Ribbon Voice Threat Prevention?
No, good question again. So analytics is the key piece that holds this whole solution together, because that's the place where we detect anomalies. So that's a key piece in the solution. Now, what we need to add on top of that is reputation scoring, which, as I said, is a Ribbon managed service. It's a SaaS service, and that's where we bring in the local information and the global intelligence and come up with the real-time scores. So if you want to take action or even get alerts on a real-time basis, you need to put reputation scoring on top of analytics to provide that holistic solution.
Perfect. Yep, absolutely. Thanks, Ram. And then just one more question. Well, I don't have a Ribbon SBC. Can I still use Ribbon Voice Threat Prevention?
No, absolutely. I mean, so what we have with the Ribbon SBC and PSX is an integrated solution. So we put all of these products and services together, and we test this end to end to provide an integrated solution to the customer. But if the customer has third-party SBCs, enterprise has a third-party SBC, we can absolutely work with a third-party SBC, because we do have interfaces, SIP interfaces into the solution, which should be adaptable to third-party SBCs as well.
Perfect. Very good to know. Excellent. All right, Ram, Dan, thanks very much for this presentation. Thanks everyone for joining us today for the webinar. Any final comments, Dan, Ram, before we close?
No, other than to the person who asked the question, or to anybody else, right? Reach out to a Ribbon contact, or on our website. You can contact us and you can ask specific questions, and we'll get back to you right away.
Absolutely. All right, well, folks, thanks very much. We have a link to the survey, so you can let us know how we can do better on our future sessions. So please let us know how we can do. Otherwise, we'll talk to you all very soon. Have a great rest of your day.
Thank you.